So this is we're going to start talking about combination circuits. So here I have a circuit to the right, and I want to find the total current supplied by the battery and the voltage between A and B, basically the voltage of the 180 ohm resistor. Now there's a problem with this circuit, and the problem with this circuit is I can't classify it as a simple series or simple parallel circuit. There's some things like this 110 ohm resistor which are in series with the battery, and there's some things that are in parallel, the 180 ohm resistor and these two are in series with each other. So it's really hard to classify what this really looks like. This is a big problem with what we've done so far because it's not a series circuit, it's not a parallel circuit. I can't say current in all the resistors is the same or voltage in all the resistors are the same. So what am I to do? I'm going to try to make it one. I'm going to try to use the idea of equivalent resistance to try to see if I can simplify this circuit down. And the first two resistors that I'm going to simplify down are these two that are in series with one another, the 220 and 250 ohm resistor. Now if I wanted to replace them with a single resistor that would do the same thing, I would have to replace them with a 470 ohm resistor, the sum of 220 and 250. So there I've done my first step, replaced two of those resistors. Now I have a section here that I've highlighted that it looks like it's in parallel. Maybe I say, well, if I have a 180 ohm resistor and a 470 ohm resistor in parallel with one another, how would I calculate what is one resistor I could replace these two with that would do the same thing? Well, I could calculate its equivalent resistance, and you find that it's a 130 ohm resistor. So we now end up with something that looks like a simple series circuit almost. We could take this one step further if we wanted to. 130 ohm resistor. There we go. 110, 130. What can I simplify this down to get a single resistor? Well, the equivalent resistance of that mess of a circuit we had back here, if we work all the way through it, so this circuit here, its equivalent resistance if we work through it is 240 ohms, if you add everything up correctly. What I can then do is answer the question about current, 0.1 amps, and from there I can answer the question about voltage between A and B. V equals IR, 13 volts. And so there I would have solved the problem. This would also happen to tell me if it was 13 volts here, it's 13 volts across both of those. If I know the current here and the current here, which, well, I do. Well, I guess that'd be the current. I know the current through both of these. I could calculate the current through these and show that that's going to work out to be a parallel circuit. So you could actually work backwards through this process once you know total current and voltage across certain parts to actually solve other parts of this circuit. This is one way to deal with more complicated circuits, what I call combination circuits. Usually it's using equivalence resistance in order to simplify the circuit down to the simplest possible circuit you could have, a battery and a resistor, and then you expand out from there. What we'll look at in the next lesson is a way to work on combination circuits in a slightly different way that is actually a little bit more robust.